Hello student, today we are going to discuss about class 12 physics ncert example problem, the question from the photoelectric effect. Okay, actually term 2 exam many question, the problem question is asked from photoelectric effect. Okay, if you want more video you can go and see in my playlist. Okay, even sample paper solution also I am given in a playlist. Okay, thank you for watching my video. Okay, now we'll be seeing the solution for this 11th chapter, third problem we are going to discuss. Okay, actually they are given the three wavelength. Okay, so one is for the first color, okay, 390 nanometer, second color 550 nanometer, third color 760 nanometer. Okay, the first color is the violet, second color is a yellow with green, okay, like a combination, like a, then third color red. Okay, they asked energy for each color, E1, E2, E3. Okay, that is the first question. Energy in the unit of EV they want. Okay, the next one, which is suitable for the next question, the two question they asked. Second question is for, you have to refer the tabular column. Okay, the first will complete the first question, wavelength through the energy. So first question will do. Okay, it is a E1 energy I am going to calculate. Wavelength is 390 nanometer. Okay, including mathematical calculation I am going to teach. Okay, so it is for E1 energy I am going to calculate. Okay, if you like my channel, please subscribe. E1 E is equal to H frequency. Okay, the first wavelength. Okay, C is equal to wavelength into frequency. If you want frequency, C divided by lambda, Hc by lambda, because frequency is equal to C by lambda. Okay, now H is how much? 6.67 into 10 power minus 34. It is going to be the Planck constant value. C is 3 into 10 power 8 meter per second. Okay, the next one, it is 3. Next wavelength is 390 nanometer. Okay, nanometer to meter, if you want conversion, nanometer to meter, 10 power minus 9 you should include, 10 power minus 9. Always the problem you should do in a meters. Okay, nanometer, 390 nanometer to meter, 390 into 10 power minus 9 meter. Okay, now we have to do the problem. Energy 1. Okay, energy 1. Numerator, Planck constant 6.63 into 10 power minus 34. Okay, into 3 into 10 power plus 8. It is C value. Denominator 390 into 10 power minus 9. Okay, now we will be doing multiplication of this two. 6.63 into 3. Okay, 6 into 3. It's almost 18. Okay, 6.3, almost 19 will get. Okay, 3 3 9 8 18 19. Okay, so 19.89 as a numerator into 10 power minus 34 plus 8. Okay, it is in a numerator. Then denominator 390 into 10 power minus 9. Okay, one more thing also we have to do. So already they asked the problem in EV. Okay, this two solution, 34 plus 8. So what is the value I get now? It's going to be around 26. Okay, so 34 minus 34 plus 8, the power will be become as a 26. So 19.89 into 10 power, it is minus 26. Okay, denominator, what is the value? 390 from 10 power minus 9, from denominator to numerator if you are bringing, 10 power plus 9 will be there. Okay, so I want to move this decimal this side. Okay, what will be there now? 1.989 divided by 390 into 10 power plus minus 25. Okay, one decimal we moved. No, you can reduce the one power. Okay, minus 25 into 10 power plus 9. Okay, now see here, this two solution, minus 25 plus 9, I will get as a 10 power minus 16. Okay, just a normal subtraction you can do. Okay, 1.989 divided by 390, it's going to be called as a E1. Okay, Next, what I can do now the energy unit, it's going to be joules. Still I'm not converted as a EV. Okay, so first we'll learn what is EV. Okay, this is a step I'm going to use with the all the problems. Okay, no need to calculate again and again. Once you calculated this much, means you can use the same step for the upcoming problem. Okay, so EV, electron volt, is 1.6 into 10 power minus 19 joules. Okay, now you have to convert joules to the EV to joule. This much number you should multiple. It's sorry, EV to joules, this number you can multiple. Joules to EV you should divide with 1.6 into 10 power minus 19. It's going to be converted as a EV. Okay, this number if you are taken means joules to EV, if you want to convert this much number you should divide. Okay, so already I have the value of joule, energy 1. What is the value I have? 1.989. okay, into 10 power minus 16. okay, wavelength, it's going to be called as a 390 into the electron value 1.6 into 10 power minus 19. Now the unit is in joule. Okay, unit in as EV. Okay, electron volt. Okay, this is the wavelength. All the wavelength is given in a nanometer. Just I'm going to replace here second one, third one. Okay, first we'll calculate first one. See here, energy 1. So this, if you are taken as a numerator, plus 19 will come. So E1 is equal to 1.989 into 10 power minus 16 into 10 power plus 19. Denominator will be 390 into 1.6. Okay, now this 2 no, minus 16 plus 19, I will get 10 power plus 3. 10 power plus 3. So E1 is equal to 1989 divided by, here point will come, 390 into 1.6. okay, E1 is equal to, because of this 3 zeros you can convert as a 1989, this 3 decimal you can move, divided by 390 into 1.6. okay, this is a final calculation will give us an EV. Okay, the same formula you can use for the all the energy. E1 energy, if you want, 1989 EV divided by the first wavelength 390. Okay, second one E2, if you want, 1989 divided by 550, same EV. Okay, then E3, if you want, 1989 divided by the third wavelength 760. Okay, it should give the EV. Direct problem only. Okay, first calculation alone it will take a lot of time. Once you calculated this, the same calculation will be applicable for all the places. Okay, otherwise you can do separate also. First I will calculate the E1. Okay, so E1 this much divided by this much. Okay, 1989 divided by 390. First we will see how many times will be get. 1989 divided by 390. Okay, sorry, electron value here 1.6 will be there. 1.6. okay, that I forgot, right? Only wavelength we have to replace. Okay, so this 2 multiplication will give, first we'll see 1989 divided by 390 into 1.6. okay, first we should do multiplication, then you can do the division. Okay, this 2 multiplication, 390 into 60. So what I can get now, 0 4 2 2, the next is 0 9 3. The answer will be 0 4 1 1 6. So one decimal is there, so you can remove this 0. So 1989 divided by 614 EV, it is for energy 1. Okay, so now we have to do this calculation. 1989 614 division, normal division. Okay, so it is going to be called 3 times. 1842 will come 3 times. Okay, 147.0, almost 2 times will be there. Okay, 2 times means what will get 614 2 times, 8 to 12, 1 2 2 8 will get. Okay, so E1 is approximately 3.2 EV I will get. Okay, now E2, what is the wavelength for E2? E2 calculation the same. Okay, same formula, HC divided by lambda into 1.6 into 10 power minus 19. This everything I calculated, including nanometer we calculated as a 1989 divided by 1.6. Here only you should multiple with the wavelength 2. Wavelength 2 is given as a we know already 550, okay, which is going to be called as a yellow green wavelength, okay. So this calculation what we'll get, first we'll do multiplication of this two, okay. So 550 into 60, one decimal will be there, 3300 again 055 so 1989 divided by 880, answer will be in a EV, okay. Now we should do the division for this number, 1989 880 division for this number, almost will get as a 2 times, so 1760 as a 2 times, okay. So subtraction will give us a 9 2 1, okay. Again point 0 1 7 6 zeros, again 2 times, okay. So answer will be for this E2 is 2.2 EV. Now I am going to calculate with the E3, okay. So E3 is equal to 19, the same number, wavelength alone will be different, okay, into 1.6 and the value of wavelength 760, okay. So the unit is going to be called as a EV. So this calculation already I told you how to do, okay. Now we'll be doing with solution for this. First we should do multiplication of this two, okay. 760 into 16, one decimal will be there, don't forget to that, 4560, then 067 06121, okay, one decimal will go, okay. Now numerator 1989, denominator will be 1216, okay. This is called E3, unit will be in EV, okay. Now division 1989 1216, 1216 as a one time, just a multiplication only, it's you can easily do this kind of calculation, okay. So again the subtraction will be the remaining value will be there, okay. 3 will come here, 7 will come here, again 7 will come here, 0, okay. Close to this value 7 to 96, so how many times? No, 6 time, okay. Then further you are doing 3 will come, okay. So the answer will be for this 1.63 EV, okay. Now we calculated all 3 energy as the beginning of the class. So I said, so we are going to calculate the energy for this 3. E1 energy I got as it's going to be 3.2 EV, okay. E2 energy 2.26 EV, okay. E3 energy 1.63 EV. The problem you should do in EV, electron volt, okay. The problem you should do in a electron volt, then only the answer will be correct, okay. Now the final conclusion I am going to give you, okay. They asked the second question, the first question over, second question, which material will emit, which material is suitable for energy, okay. So work function, the minimum amount of energy is required to emit the electron from the metal surface, we can take it as a work function, okay. So the least value should be more than work function, okay. First E1 energy will take it, okay. How much? No, 3.2 EV. Now we'll see which material and all is suitable for this energy. So they asked you to refer the tabular column 11.1. So I am taken as a 11.1. So it is a incident energy, okay. The material which is suitable, the more than 3 point, the value will be the incident energy will be 3.2 EV. 3.2 EV means less than 3.2 EV. Everything we can use for the emission of the metal surface, we can use to emit the electron, okay. That means this much light is incident on this particular material, means electron will be emit, okay. So CSKNA, everything is less than this value, this material and all is suitable, okay. If this light is incident means here the electron will be emit, okay. So for E1 energy it's going to be called as a CS. Next material is the K. The next material is the Na. This and all is suitable for this incident light. Okay, that means the electron will be emitted from the metal surface when the wavelength is 360 nanometer. Okay, this material can be used for the thermionic emitting material. Okay, now E2 is how much? No, 2.2 eV. Less than this value means everything is suitable. Okay, for E2 material, which and all is suitable? No, for E2 incident light, it's going to be only CS is suitable. Only CS is suitable. Okay, so only CS is suitable. Okay, because CS is 2.14 eV required. Okay, so this is a minimum energy. It is more than that. This can be used. Okay, this wavelength is 550 nanometer. If incident means this material you can use to emit the electron from the metal surface. Okay, third one, E3. E3 I got 1.63. Okay, EV. It is less than the given material. Okay, so there is no material is suitable for this value. Okay, thank you for watching my channel. If you like my channel, please subscribe. If you want more video, you can go and see my playlist. Thank you.